So thanks for joining us today. We're going to talk about containers in production with Deis and NGINX. So flipping over to my slides here, just quickly about me. My name's Gabriel Monroy. I'm the CTO at EngineYard. I've been an early contributor to Docker, so if you ever used anything in Docker like bind mounts, the -v flag for Docker, things like host configuration, which is sort of container local configuration. These are all things that were added in Docker in the early days to make Deis possible. And Deis is a project that we created, which the technology was later acquired by EngineYard and is today one of the leading Docker passes. So what is Deis exactly, right? The best way to think about Deis is as it's really a private Heroku running on top of CoreOS. Is kind of the simplest way to describe it. Rather than being an orchestration system ourselves, we're actually a consumer of other orchestration APIs. That's not commonly known, but Deis is best thought of as kind of like a workflow layer that sits on top of something like Kubernetes. So today we are the leading Docker-based pass, and what I mean by that is Deis today has over 1 million downloads. We're seeing about 500 new clusters going up every day, and the project has, I believe, 145 open source contributors at this point. So it's used by many companies, names you know, including folks like Mozilla, Shopkeep, The RealReal, Coinbase, list goes on and on. But probably hundreds of production deployments, if not thousands. Hard to know exactly how many. So I wanted to spend a minute about talking about why Deis, why it exists in the world. How many of you are familiar with containers and are exploring use of containers today? How many of you feel like you have a good handle on everything that's out there in terms of the space and which direction you should be going? 1, 2 hands? Okay, so, and there's a reason for that, right? There's a huge pile of stuff going on. And it's great on the one hand because there's a ton of innovation happening in the space, but it's really confusing for folks like yourselves in the audience who are just trying to figure out, well, what am I supposed to do inside of my organization to help solve problems? And that's really what Deis has always been from the outset, is a way to, an open source project that is actually gluing together best of breed open source technology, turning that into something that has a proven operational model and that can scale production workloads in the wild. So some of the specific benefits of Deis are one of the things that we provide is developer self-service. And I want to be clear about this. This doesn't mean that developers could just run wild in production and deploy workloads out without any controls whatsoever. But what it does mean is that developers should be free to innovate. There's a reason you have things like dev clusters and staging environments where folks should be free to go build new things and benefit from some of the agility that containers provide. And Deis helps make that possible. And we'll talk about that a little more. Another is extreme reliability. The whole move from single system configuration management based approaches to a world of distributed systems brings with it a lot of benefits. But one of the ones that is really poignant for folks who have experienced it is this idea that when you have a node failure, that doesn't actually ever result in downtime for any of your services. The same is true for failure of availability zones or racks or network partitions of any kind. That's something unique to building these kind of distributed systems. Another side effect of this is horizontal scalability. If you're building apps in this model, you can really literally just throw hardware at the problem, scale out, and things become a lot easier to scale. And one of the biggest things about Deis, and I hit on this just a moment ago, is wrapping all this technology into a proven operational model that is actually backed by commercial support is something that's kind of unique in the industry today. So let's get into some of the technical nitty-gritty here. So how does Deis work actually? Systems like this are pretty complex, so let's walk through it. So this is a system diagram of Deis, and there's really 3 main components to the system. The first is the control plane, which is really the brains of the platform. And inside of the control plane exist, about a dozen or so different microservices. They're all themselves powered by Docker containers. But these are things like a containerized Ceph cluster, because at the end of the day, there needs to be some storage subsystem that's highly available. So we actually rolled our own containerized Ceph, which is actually reusable outside of the project. But and so the control plane is really where API interactions from developers come in who are looking to drive the platform, CI/CD systems that are looking to drive the platform, like Jenkins or something. That's where you're talking to. The data plane is where the work gets done. That's where you actually, you think of it as your worker cluster. That's where you're actually, the containers get spun up. Now, in between those two things sits a scheduler or an orchestration system. And one of the interesting things with Deis' architecture is we're, I believe, the only platform as a service out there today that actually has available pluggable schedulers. So we can actually use, we currently use Fleet, CoreOS's Fleet for scheduling. I'm going to be demoing Kubernetes, which is a technology preview we have. But we also support Docker Swarm as well as Mesos via the Marathon framework. So that scheduling and orchestration component is pluggable today. And the last component, and what we're going to be spending most of the time talking about today, is the router mesh. And the router mesh is how the platform itself, as well as all of the containers that run on the platform, get exposed to consumers outside the cluster, be they on the internet or inside of an internal network. Now, some certain things that we don't do on the platform that I actually want to specifically call out. Backing services. So right now, it's as someone who helped work on Docker's volume subsystem, I'm not of the belief that we're yet ready to run production data stores inside Docker containers. I think the operational model is not yet fleshed out. I am not very comfortable with my data living under varlib, Docker, VFS, some GUID, whatever. The backup and restore procedures for some of this stuff are a little bit different, and you can get yourself into trouble. And if I'm a DBA, I'm not one to take risks. So, backing services right now, we connect to those externally via environment variables. Now, you can run those in containers. People do this successfully. It's just you have to understand the risks, and we want to, part of our job with Deis is to make sure that we put kind of the bumpers on the bowling lane and make sure you don't actually hurt yourself. And running data stores inside containers is not something we support natively. Things like monitoring and logging. Many of the folks who deploy Deis already have their own systems for how they want to do monitoring, how they want to do log aggregation. So we do have some features, actually quite a bit when it comes to logging. For things like monitoring, what we're interested in is exposing APIs that allow you to plug into whatever monitoring systems. We see a lot of Datadog, a lot of Sysdig, a lot of New Relic in the wild. So this is actually a workflow diagram of what happens when you git push something into a Deis cluster. So the first stage that we're going to do is you're going to hit a builder component in the control plane, and that's going to create a new build. And that new build is going to be added to configuration, which is basically a set of environment variables. Those two things are going to be smashed together into something that we call a release. And that release is going to be tagged with a version number, version 23, for example. We model those releases as Docker images inside of a cluster local Docker registry that's distributed and highly available and part of the cluster infrastructure. This is really, really important to make sure that things are fast when you're looking to scale or in the event of network partitions. You really need to have this stuff cached locally. So we store that in a local registry. Then we go out and we talk to this pluggable scheduler / orchestrator, and we say, hey, the way we want to orchestrate the system has changed, or this application. So let's affect a rolling deploy, and let's update some of these containers, roll out new versions, have them gracefully come up, publish to etcd when they're ready, and then etcd will inform the router mesh that the new containers are ready and slowly start shifting traffic over to the new containers. And we do that in a way that has zero downtime with features like optional health checks at the HTTP level and stuff like that. This is kind of a general overview. But what I want to do is walk you through a video of this, because it's always helpful to see this in the wild here. So I'm going to hit play and hope this video plays. Let's try and reload. So we're going to start out with an example Go application. And I'm going to use the Deis command line client, which is what you distribute to your developers. And they're going to say Deis create Go, which is going to create a new application space inside the cluster for this Go application. The interface is then as simple as git push Deis master. It created a git remote automatically when you created the app. And what this is doing is it's hitting our builder component, which is actually proxied to by NGINX. And the builder component is a Git server that is running a build pack. And you can see the build pack already sort of completed. It completed compiling a slug, which is essentially a Go binary. And now what it's doing is it's building a Docker image from that slug. So I didn't actually have to build a Docker file. I didn't have to do anything. I literally just packaged up my application code and git pushed it, and the cluster is building this into an image, packaging it up and shipping it to a cluster local registry. And then we're going to call out to the orchestrator in a moment here to actually run this across the cluster. So if you want to take a look here, you can see that we actually have a special custom slug runner image that we inject the slug into at build time. And that gets pushed out to this private registry that that you're seeing right now. And what we do is, as you modify configuration, we're actually talking to the Docker registry APIs to actually inject environment variable configuration at the registry API level. So at this point, we're done. The git push succeeded. And if I curl go.gabertv.io, which is the domain for this platform, you can see powered by Deis, release v2 on the container name. Now what I'm doing here is doing config set. Now this is really, that's pretty useful, of course, the build workflow, but you're obviously going to need to configure your applications at runtime and make them slightly different. So you're going to, this is a stand-in for how you might connect to an external database, like a Postgres database, or add a debug flag, or wire up to a memcache or something like that. You would update environment variables. This one happens to update the powered by section. So you can now see powered by Docker. So at this point, we've built an application, we've updated configuration. Now it's time to scale up. And scaling is as simple as Deis scale, process type equals number of containers. And you can actually scale on different dimensions. So if you're familiar with Heroku, they have the idea of process types. So you can actually put a proc file in the root of the repo and scale on different commands. So here you can see we just curled a couple times after scaling, ran Deis logs, and you can see that all the logs are actually aggregated for the developer here across all the containers, which is a really, really powerful feature and really helps with folks debugging. We also maintain this append-only release ledger, which tracks every single change every developer makes to either a build, pushing a build, or a config change, as well as one-off commands that can be run against the cluster to do things like schema migrations or admin tasks. So this is incredibly useful, and using this ledger, because we because we store everything as Docker images, we actually have a history of the application at every point in its lifecycle. So we can use this Deis rollback command to roll back to any past point in time. And you'd think, well, that might take a lot of storage, but because of the way Docker uses layers, it actually takes a lot less storage than you might think. So rollback, takes a moment here, but we're now back to v2, which should print powered by Deis again. And now you can see we're on actually release v4 with a different container ID. Another feature that we have, which I touched on, is the ability to collaborate with other users. You can actually have LDAP, Active Directory integration, wired up to this. A ton of other features that I'm not showing you here, things like memory and CPU limits, tags to pin workloads to specific host types. So, for example, if you want to separate queue processing jobs from web workers and things like that, you can leverage Deis for all that. So, moving right along. How do we route traffic in Deis, right? Very interesting question. I guess you guys probably know the answer here. We use NGINX is the answer. And, but it's actually a specialized version and packaging of NGINX. We use etcd to store configuration data for how we're going to configure the web server. Confd is used to watch etcd for changes and then re-template out NGINX config files, as well as things like SSL certificates, and then update NGINX. So, why are we using NGINX? It's an interesting question. Now, we've evaluated lots of different solutions in the space. One of the things that we found was NGINX has a ton of features around HTTP application management that simply aren't there in other alternative open source solutions. HA Proxy, for example, is a really great TCP-based load balancer. It's very lacking in some of the more advanced features that a lot of our users need to deploy HTTP-based microservice architectures. Those of you who have done the evaluations yourselves probably know what I'm talking about. But it also has a very active community. Things like WebSocket support were added recently. TCP load balancing was added recently, and the project seems to be moving at a good clip in a positive direction. So we're quite pleased with it. So some of the things that the Deis router exposes, thanks to NGINX, is this entire list here. Custom CNAMEs, virtual hosts for applications. Session affinity. I'm not going to go through all these things, but this is incredibly powerful feature set. But one of the things that we like to do is to really simplify the operational model around this. So rather than making folks edit configuration, NGINX configuration by hand, with Deis, with the router mesh, configuring the router looks something like this. So you'd say Deis ETL, which is our operator tool, config router, set enforce HTTP is true. So anything HTTPS gets automatically redirected to HTTP gets redirected to HTTPS. We're enabling the web application firewall with the default rule set that we ship. And we're also enabling strict transport security for HTTP. One command updates etcd, retemplates the configuration, and everything is live with NGINX. And all of the tunables that we have for the router work in the same way. So it's pretty powerful and makes it really easy for operators. Another thing that we added was the ability to do per application SSL and TLS. And this is really important for platform as a service solutions. So what does this look like? The tool I showed you before was Deis ETL, which is the operator tool. This is the Deis CLI. So this is, ideally the developers are going to be the ones, the person in charge of the app is going to be the one who's going to want to set up the SSL, or that's the ideal model for a pass. And the way you do this is you add a custom domain, so a custom CNAME to an app. Example.com in this case, and then you use the Deis certs add command to add a certificate, a key, and an optional chain, validation chain, to get distributed with it. That also updates etcd, which updates the router templates, which soft reloads NGINX and results in this going live on the platform in a matter of seconds, really. So this is a pretty powerful model for getting per app SSL deployed. So with that, I actually want to show you a little bit about what this template looks like. How many of you here are familiar with NGINX? Consider yourselves advanced NGINX config folks. A handful? All right, well, this might scare you. Let's see if I can get out here. Presenter mode. So this is the Deis project, and what we're going to do is we're going to jump into the router subfolder. This is actually the Deis router component, and it's all packaged up as a Docker image. All of our components in the system are all packaged and run as Docker components. One of the patterns we like is to actually have a rootfs folder that we can track all of basically the root file system for the entire container. What I want to show you here is inside of confd. By the way, how many of you here are familiar with confd? Okay, a few of you. So confd is basically a lightweight templating system that uses etcd, which is a key value store, not unlike something like S3. And what it allows you to do is update key value pairs and then have those watch on those key value pairs, and essentially use that to drive configuration via confd. So I'm going to pull up the nginx.conf template. This is 578 lines of basically a Golang template. So for a simple example of how this works, worker processes. This is something configurable. I don't know if you guys can see this. Let me zoom in a little bit. This is something configurable inside of Deis. So what we do here is we say, get the value for Deis router worker processes, or if that value doesn't exist, fall back to auto. And that's a pretty good model here for a lot of kind of default values, things like max worker connections. But then we get down into things like enabling the firewall. This gets pretty hairy in terms of how you template this file out. Then we get even hairier. This is strict transport security, but let's go down into the section for, this is for custom domains. We range over custom domains, and we set up basically virtual host mappings for each custom domain. So this is pretty tricky stuff, but one of the things that is really advantageous is because we have so many folks running this in production, there's about 20 people over the many months that this has been out there who've actually helped us tune this, and most of them are much better at NGINX than I am, frankly, and so this has been really battle hardened, not just at a single customer site, but across hundreds and probably thousands of different customers using this same NGINX config. So it's actually a really useful place to start if you're looking to do something dynamic like this. Now, this is obviously sort of a verbose way of showing you how we do some of these tunables. We do actually document this stuff inside of the documentation under, if you go to deis.io or docs.deis.io, the documentation tab, customizing Deis and customizing the router. You can see here settings used by the router, where we enumerate all the different etcd keys, how you can drive configuration, doing things like connect, read, and send timeouts for all the major components, gzip compression tunables, HSTS, SSL tunables, pretty much anything you can envision. And so we get lots of folks who wade into the project and wind up customizing this component. It's the router, as a component inside of Deis, the router is far and away the most customized component in the system. So now let's say that what we had inside that template didn't meet your needs for whatever reason. I showed you before that was actually a Docker image inside of Deis, and one of the things that we see folks do quite often is, they'll say, well, I want to do something wildly different. I want to custom error pages, and I want to use NGINX Plus, or I want to do something wildly different. Well, as long as the router implements the same interface in terms of the tunables, you can actually, or even if it doesn't, frankly, you can configure your own image by doing Deis ETL config router, set image equals some path to a Docker image. And then you just simply use Deis ETL to restart the router mesh using this command, and that will allow you to use your own custom Docker image for the router, including NGINX Plus. And we do have a number of folks who are running with NGINX Plus with Deis. That dashboard is pretty hot. So I want to talk for a minute about NGINX open source. One of the things that we're relying on heavily is soft reloads. And some folks may be wondering, well, how does this scale specifically for putting containers into production? And the answer is extremely well. And we've actually done some scale testing, and the actual answer is surprisingly well. So I want to go into a little bit of how this works. So how many of you are familiar with the soft reload process for NGINX? A few of you, many of you? Okay, so I actually got a chance to look at the C code recently and had a chat with some of the folks about some of the details of this last night. But the general process here is you update configuration, and then you send a SIG hub to the NGINX master process. That will then do a syntax check on the new configuration. It will then move on to basically prepping the new workers. Starts by opening some logs and some listening sockets, and starts up the new workers. Once the new workers are serving traffic, O workers close down their listen sockets, complete in-flight requests, and then the workers get reads. Pretty straightforward stuff, and actually works quite reliably. So in the initial state, if this is your simple 3-worker NGINX tree, you would have, while the soft reload is in progress, that second process in the list there has an in-flight request, so it says shutdown in progress, and then eventually it goes away. Now, with a platform like Deis, where you're actually tracking the container topology, you're seeing these shutdown in progress processes occurring pretty frequently. And there's a concern: is this going to be able to keep up? And the truth is, it really keeps up quite well. So we're quite happy with that. Now, some production concerns with Deis specifically and with NGINX in this kind of approach. So the first is, you really want to scale out that router mesh to have as many instances of NGINX as you need. So we default to 3, but we see folks running with 5, some folks running with 10. It depends really on how much bandwidth you need at the edge in order to terminate. But we see 3 working for most folks. Another thing is graceful upgrades of Deis. Upgrading the platform is always a problem with solutions like this. We actually have a new graceful upgrade command, and what it does is it sort of stops everything in the platform except for the router mesh and any applications running in the data plane to ensure that you don't have any downtime. And then there's an upgrade takeover command which upgrades the rest of the platform and does a zero downtime upgrade of the Deis platform components. Again, this is really important and something that we take very seriously, the sort of operational hardening of how Deis actually works in the real world. Now, some potential gotchas. We've noticed NF contract can be a problem at high scale. So NF contract is essentially the Linux kernel doing network connection tracking for things like IP tables. There is a limit to how many active connections can be tracked, and oftentimes you're going to need to bump that tunable. We bump it by default in the CoreOS boxes that we ship, but you're going to want to watch out for that. Another is long-lived sessions. I had a conversation last night with some folks on the NGINX team, and if you're not careful with your TCP sessions, if you leave your TCP connections open, you can actually leak workers using the NGINX soft reload feature. So you really need to be careful that if you're using soft reloads, you're actually closing connections every once in a while, or having those connections time out due to inactivity. Otherwise, it can be a big problem. And one of the biggest things that can bite you, if you're using, this is just generally confd and NGINX, is inconsistent template output, or more specifically, idempotent template output. If every single run of confd results in a slightly different ordering of the config file, confd is going to be sig-upping the NGINX process when nothing actually changed. It's just that you're iterating over a map, and the map is sorted differently every time, and that results in basically you sig-upping everything way too often. So if you're going to use this approach, make sure that your template output is consistent every time, and watch those NGINX logs. So I got a few minutes left here. I want to talk a little bit about how Deis scales more broadly. So cluster schedulers are a thing. This is how distributed systems work. Now, you can generally know a cluster scheduler by a few common patterns. They typically have declarative interfaces. I want to run this many things. They also have placement constraints. Things like, I want these workloads to run on these hosts. They feature things like affinities and anti-affinities, as well as interfaces for service jobs and batch jobs. Batch jobs being a job that runs to completion and returns an exit code. Service jobs being long-running jobs. Now, for Deis, it was really important for us that we choose a scheduler that was resource-aware, that had host constraints. We wanted to pin stuff to specific hosts. For example, NGINX should be on these 3 boxes that are connected to a special network. As well as things like co-scheduling, soft anti-affinity to spread out workloads for HA placement, and global scheduling. Global scheduling being the ability to schedule something and have it running on all boxes. That's a very useful pattern for sort of management and agent-style architectures. So there's a few options out there that support scheduling Docker natively. Fleet obviously is what we use today. Docker Swarm is making some good strides. Mesos is obviously the battle-tested solution. And then there's Kubernetes. And what we found is that Kubernetes actually strikes the right balance of lightweight while also providing a good broad feature set that meets our selection criteria. So I want to talk for a moment about Kubernetes. How many in the audience are familiar with Kubernetes? How many have used it? Okay, good amount of you. So what is Kubernetes? It's an open source system for managing containerized apps, basic mechanisms for deployment, maintenance, and scaling. This is direct from their README. Now, Kubernetes is really a really useful building block for building higher order orchestration systems, and that's what we're using it for. So it features some core concepts. I'm not going to go through these in great detail, but a cluster is a pool of nodes. Pods are this idea of sort of a grouping of containers that run across a distributed system. Replication controller is this idea of I want a certain spec of a container, but I want a certain number of copies of those spread across the cluster. Services are what you expose inside the cluster for intra-cluster communication and service discovery. And labels are a way of loosely organizing metadata inside the cluster. So some very powerful concepts. Now, some of what makes Kubernetes unique Now, Kubernetes, unlike Docker Swarm, for example, also unlike Mesos, features shared namespaces. So, when you run a container inside of Kubernetes, it actually creates a shared namespace where you actually run multiple containers, a pod, and all those things share, a network namespace, a mount namespace, and they're really volumes and things like that, secrets, things like that. It's a very different model and a very powerful model for things like atomic scheduling. There's also this pod and service networking model. For those of you who may have come across Kubernetes in the past, one of the things that immediately turns folks off is, I need to run an overlay network to make this thing work, or I need to assign a subnet to every host in the cluster. Well, there's a reason for that. The reason is that every network, every pod that gets scheduled onto a Kubernetes host gets its own IP address. And that makes it routable uniquely across the cluster. And it's a really powerful construct because you end up getting to move away from this port brokering world where you're dynamically exposing a port that gets mapped late bound to your NGINX web server that you run gets bound to 49153. And you have to figure out, that's the port, but really what I wanted was 80. And so how do I actually publish that to everything that needs to know that it's on this new weird port? Well, if you have the namespace and the container binding to its own address, it can do a listen on whatever port it wants. And that really dramatically simplifies service discovery inside the cluster, allows for things like DNS-based service discovery, and everything just kind of works. You do pay the price for complexity on platforms that don't support container per IP natively, but most cloud providers are getting around to this, and if you control your own gear, this isn't a problem. There's also solutions like Weave, Flannel, and Project Calico that offer solutions for this as well. Biggest thing that makes Kubernetes unique, though, is the Borg and Omega team. It's very clear to someone like myself who's done a good deal of research on cluster scheduling that the folks who actually worked on Borg and Omega are the ones working on the Kubernetes team. You see, the reconciliation pattern, applying a desired state and current state. The whole idea of not using port brokering was actually a lesson that they learned inside of Google and applied to Kubernetes, which is probably best viewed as a rewrite of Borg, their internal cluster manager. So, very, very unique project, and there's a lot to like about it. So why would you use Deis and Kubernetes together, right? That's a really, really interesting question. And I want to walk you through a quick example of deploying a Meteor app using raw Kubernetes. So it kind of starts like this. Step one, you build a Docker image, right? And this assumes that your developers have Docker loaded on their laptop. They got a Docker engine running, that they know how to build a Docker image. You have Docker files for everything, but not that hard, right? Step two is you got to ship the image, right? You got to move it to a registry. Now, one of the things you quickly learn if you're operating these systems in production is you don't actually want to go to Docker Hub or Quay or somewhere else, some third party to pull your images. You need a local registry that's caching your images local to the cluster. Otherwise, everything's going to be way too slow. So you got to stand up a registry. Well, it's kind of tricky to set one up and maintain it, but it's doable. And the last thing is you got to run. The application. Build, ship, run, right? And so for Kubernetes, you got to create a replication controller, which is how many of these things you want to stamp out. And then you create a service, which is how you want to expose this. And those commands are pretty simple, right? What you have to do, though, is you actually got to write out the definitions for these files. And I was actually in a talk that Kelsey was giving earlier about some of the, someone asked, how do you actually write these files? I guess the answer was more or less very carefully. You got to be extremely careful with this. It's not just this, it's the service JSON. And by the way, these are the JSON representations. They're easier to write in YAML because you don't have to worry about the commas and semicolons. But there's still a lot of kind of human error here in writing this stuff. So Raw Kubernetes can be a little frustrating if you're trying to bring this to a software team and say, hey, write this kind of arcane syntax. Now, I expect that'll get easier over time, and there'll be less of a problem. But right now, Deis offers a pretty good answer for this. A Heroku-style CLI that actually translates this stuff into those manifest files. So you get all the benefits of Kubernetes declarative orchestration, but you get an imperative workflow for developers who are more comfortable with that kind of model. So we feature a Heroku-style CLI experience, a build server that allows you to do git push deploys, though those are actually optional. You can ship raw Docker images directly into the platform too if you have a CI/CD process. Cluster local artifact storage backed by Ceph on the cluster, containerized Ceph. Extremely important for real-world deployments. An NGINX router mesh that features things like custom CNAMEs and TLS, which are extremely important for real-world deployments, as well as a whole complement of operations-ready features, log routing, aggregation, configurable syslog drains via one command, user management with LDAP and Active Directory integration, all the bells and whistles you need to actually put this thing into production. So steps 1 through 3 with Deis. Deis create Meteor, git push Deis master, uses the build pack to build everything, ship it to the local store, and then Deis scale web equals 2, because we actually don't support scale on deploy, although I suppose we could. But this is a lot more palatable to most folks. I was going to do a demo. We're getting out of time here, so I'd actually like to talk just quickly about a couple other things. What's next for the Deis project? The biggest thing we're doing is right now, Deis actually sits outside of Kubernetes, and Deis itself runs on Fleet on CoreOS and schedules out to an external Kubernetes cluster. That's how we support things like Mesos, Docker Swarm. We haven't essentially picked orchestration system to re-platform on. Well, guess what? We've picked. We're going to be re-platforming on Kubernetes, rebasing the entire system. So there is, in a branch you can see on GitHub now, Deis itself running on top of Kubernetes, scheduling back to Kubernetes, which is a really nice way to run, for example, on GKE or CoreOS on AWS. Some of the things we're working on, an NGINX Kubernetes load balancer integration. There's active work going on in the Kubernetes community to make load balancing a first-class citizen in the platform. And we are helping drive that effort inside of the Kubernetes community to make sure that NGINX works extremely well as an edge load balancer inside of the Kubernetes world. Now, one of the things we're exploring, we haven't yet decided, in a perfect world, NGINX would be completely API-driven for configuration. Be able to create new upstreams, all those crazy tunables I showed you, turning on HSTS, that should be an API call, right? But we're not in that perfect world. I understand it takes a while, to get there. So in the meantime, what we're looking at doing is there a way we can do some Kubernetes native backends in memory via some kind of third-party module? So if any of you are working on Kubernetes and are interested in this effort, please come reach out to me. We're looking to kind of get a group of people to help work on making NGINX plus Kubernetes extremely good fit. So last thing I'm going to talk about here, we have an open roadmap and planning process. This is kind of unique as far as I can tell. So we have a meeting once a month where we basically share the roadmap with everyone. We walk through what people are looking for. We have a very high turnout on these calls typically, and it's a good chance for folks to voice their concerns about where the project is going and push their pet pull requests and things like that. So that's the first Thursday of every month. So with that, I want to thank you all for having me here today. Thanks, everyone. And open it up for questions. Anyone have any questions? Shoot. I'm sorry. Okay, yeah, okay. The question is, does shifting to Kubernetes mean dropping the Mesos support? And the answer is no. In fact, we're working very closely with the folks over at Mesosphere. The only difference is that in order for us to get a really solid Mesos integration, we would have to write our own framework. It turns out Marathon does too much, basically, for Deis. Guess what? There's a really great framework out there that does exactly what Deis needs. It's called the Kubernetes framework. So we're just going to build on top of that and help contribute contribute to that effort going forward. So we're also working with the folks over there on a DCOS plugin. So it could be getting Deis up and running on DCOS can be as simple as DCOS install Deis. Great. Other questions? No? All right. Thanks, everyone.